Hello everyone. I want to let you know that this is going to be the last time we do a physics lesson together. I wish we could be together in person, but I don't want to let this moment pass without going over some things that I think are very important with you. So I'd like to take you back to the very first day I ever taught you. And this was September last year, so I guess it was September 2018. And I went through talking to you about the course that I was about to start teaching you. In fact, both courses that I was lucky enough to be able to teach you. And there was one point in particular that I wanted to emphasize that day. I wanted to emphasize to you that physics is the search for truth. At this moment, 2 years ago, I played you a little clip. It was 30 seconds or less. I want to play it for you again now.
We have a bunch of questions. Have we ever seen anything like that before in American governance? Did this thing actually end? Is it still going on? Am I asking the right questions here? That's the heart of the matter, right? Should those dots be connected? Do I have that right? Am I right to see it that way? How are we supposed to know? What do you make of that decision? Is that accurate? What does that sound like to you? Is that weird? What does that mean? It sounds a little nuts, right? Is it fair to say? What's going on with that? Why is this happening? Why is that? Why is that? Why is that?
I told you at the time that the search for truth is probably the most important thing that you were going to get out of my class. And I hope I didn't let you down. I hope you guys realize that you're going to hear all kinds of nonsense in life. And I want to make sure you realize that you can find truth. You don't have to believe things that you hear. I hope I showed you over the course of the last 2 years that one way we can find truth is by doing experiments, by setting up systems, by changing one variable at a time, and by carefully collecting data. And I hope I stressed enough to you, trust your data. Even when you think things are going wrong, trust that you're doing it right. Collect all the data, see what kind of pattern emerges, see if you can figure out what you can then do with that pattern. If at the end you can't make sense of it and you want to check your data again, that's fine. But trust it while you're collecting it, and trust it when you collect it again. When you get the data and a pattern emerges, hopefully you guys realize that you can take that data and use it to predict things. So we collected some data on masses and location, and then we were able to hang different objects on the end, and we were able to predict their mass. And you guys did a beautiful job. You were able to create a scale to determine mass, and you have faith, I hope, that what you did was accurate, and that those masses are not just some numbers that show up on a digital scale, but you actually determined how much matter is in that object. That becomes a real physical truth. This year we collected data with our Pocket Lab, where we took our Pocket Lab to different elevations and we looked at height versus the pressure drop. And we found a beautiful linear, in fact proportional relationship. And you might be tempted to think, wow, I can predict the pressure drop for any height. And although it might look that way, realize that you can't be fooled by your data, because sometimes as you continue to collect data, you might find this relationship doesn't last forever. As you get higher and higher in the atmosphere, you eventually reach a point where this no longer stays proportional. So don't be overconfident in what you find. Be confident that what you did is correct, but also be aware that there might be things lurking in the shadows that you did not consider. Keep an open mind even after you do your experiment, even after you think you came to truth. Be aware that you should still be asking questions and you should still be probing for the validity of those truths. Don't be the type of person that establishes their opinions at the age 18 and never changes them. Be open to new data. But again, trust. Trust in yourself. I also want you to realize that sometimes when we collect data and we make predictions, that those predictions can be wildly divergent. So although our science tells us really well how things behave in terms of pressures and temperatures and humidity, and we could put these into a computer, our data is so incomplete that sometimes we run the same experiment on the computer 10 times and we get 10 different answers. So when you hear scientists tell you things like a hurricane is going to do X or Y, realize that that's really not the scientist talking. That is a person on the news who is trying to make things simple for you. Realize that in reality, when the hurricane doesn't do what the person on the news tells you it's supposed to do, it's not because science was wrong, it's because the science is so complicated that no scientist would tell you with certainty what a hurricane is going to do. So understand the limits of knowledge. It's not that we don't know anything about hurricanes, it's just that we don't know enough to predict their every single movement. So be aware that sometimes people are going to tell you part truths. Dig deeper. Understand that when they tell you things, it's kind of like an average, and it does not represent the full truth. For instance, this became very important when we were talking about the COVID that had hit us just this year. You would see scientists produce models of what was going to happen, and oftentimes they didn't show you the error bars. Well, those error bars are hugely important. It shows us that, yeah, we have some grasp of what's going on, but not a complete grasp. And the more we learned, the better we were able to model how these systems were going to work. So always look for the error bars. Always look deeper than that surface knowledge that people are trying to tell you. Realize that it's not that they don't know what's going on, it's that they only know what's going on to a certain confidence level. And please understand what that confidence level is and how drastically different the outcomes might be just because we don't have complete knowledge. Knowing what we don't know is very important. Knowing that it could be way worse or way better than we predict is an important thing for us to wrap our heads around. Also, you're going to be confronted with a lot of people who are going to try and tell you bogus ideas. Oftentimes, these people are doing this because they know that they can capture those who aren't heavy thinkers. They can get hits and likes, and bottom line, they can get money from propagating false theories, conspiracy theories. Please be smart enough not to fall for things that are nonsense. Demand proof. So for instance, the fact that the earth is round, we can do many different experiments that not only will show us it's round, but we'll be able to predict what actual size it has. Please make sure you trust your own data. If you do have doubts, look up the experiments, run them yourself, and prove to yourself what should be obvious, and that is something like the earth is round. So for instance, one that we talked about when I introduced you to the graphing that you could do so easily is go to different heights above surface level, measure out how far the horizon is, and you can work out the actual curvature of the earth. Okay, and when you do this, you can actually prove to yourself in a real easy fashion, and this is just one of many experiments you could do, that proves beyond a doubt not only that it's curved, but how big the darn thing is. Finally, I want you to realize that science is never complete. Oftentimes in the news media, they present scientific findings as if they are gospel that is handed down to us from Mount Sinai. Realize science is at its best when science is wrong, because science should never be afraid to tell you that they messed something up. Especially something like this virus, when we do a study, at this time, we are rushing to get our experiment done. And when that experiment gets published, and a week later we realize, oh, we kind of didn't collect the data quite the way we were supposed to, science is brave enough to let us know. You know those findings we had? Well, they were a little bit off. That is not a failing of science. That's how science is supposed to work. Science is supposed to work by people constantly checking and rechecking and doing new experiments. And when a new experiment shows the old experiment is wrong, we are brave enough to throw away the old and go with the new. Just like Einstein did with relativity. As crazy as his predictions were, scientists realized when they saw his work that that was indeed the truth. And the old stuff from Newton and Galileo was no longer correct. Realize, though, that even with Einstein, that quote-unquote truth is conditional. There's nothing to say someone's not going to come along in the future and find something else that is even more encompassing than what Einstein did. So realize, when science gets things wrong, that's actually science getting things right. Brave enough to admit when there was a problem with the old theory, and we should be brave enough to move on with our new ideas. Finally, I hope that you guys had a lot of fun in this process, learning about the ways the universe works. And again, I tried every single time I could not to just tell you how it worked, but to have you do an experiment so you learn for yourself that that is indeed how things operate. I hope you had fun over these last 2 years. I know there were a few things we wanted to do at the end we didn't get a chance to, but that 1.75 years of time together, I hope you'll have memories that you'll remember forever. I know that I will. So I want to thank you all very much.